Ayubowan duwe puthe, welcome back to my channel again. Today we are going to start off year 11 maths lesson series. First lesson that we are going to look at is sets. If you haven't looked into or watched my video lesson that I did for year 10, please go and have a look that through as well, where you can gain a lot of knowledge in there too. The main difference today lesson and the year 10 lesson is today we are going to discuss up to 3 subsets in our maths problems. Let's have a look at the lesson today and then start off our work. The learning intention today is we are going to look at Venn diagrams including 3 subsets, and then we express the subsets denoted by the shaded area using the set notation. Then finally we are going to have a look at solving problems involving Venn diagrams and 3 subsets, of course. Excuse me. Okay, now here you can see the I have given set of diagrams, Venn diagrams. In each of these, we are going to have a look at the way of presenting. Okay, the first one that we are going to look at is the most general form, where you have all 3 subsets intersecting each other, forming 8 different sections here. That is the most general form. So in case if you've been given a question including 3 subsets, but the Venn diagram is not presented, this is the one you should be drawing. And second one is where all 3 subsets by themselves, there is no intersection. And then the third one, 2 of them intersect, one is of both of them. And then the other way of presenting Venn diagrams would be excuse me, one is a subset of the other and doesn't intersect with the third one. Then the next variation is the third one intersect with the previous 2. Or we can think of every subset is a subset of the other subset. And then finally we get these 3 variations where we have only 2 of them intersecting at a time. And I also can include another variation. Instead of the purple, I can include another one, let's say using orange. But that one is not a circle. It should be a sort of like a shape where it does intersect with the red one and blue one, but they don't have, altogether, they don't have any common area, like the very first one we had a look at. Right. The second last one is there is a subset which governs 2 other subsets, and the 2 subsets inside, they intersect. The final variation is they don't intersect. Righty. So let's move on to representing or expressing subsets denoted by the shaded regions. The very first one, I have given a few diagrams here. Let's have a look at one at a time. The very first one, okay, thinking it's common to all. It is the intersection of all 3 subsets A, B, C. Hence we can write A intersection B intersection C. Then we move on to the second one, where you can see it is the area between A and C but not B. So it's between A and C. Therefore A intersection C but not B. Therefore it is the complement of B. So intersecting the complement of B. Outside B but inside A intersection C. That's what we call it. Right. Moving into the next one. Number 3. This is same as if we had just two subsets. Irrespective of whether you have B or not, it is just the intersection between A and C. So simply A intersection C. The next one. As I mentioned before, please feel free to stop the video and write down the answer yourself before you go through with this lesson, so that you can cross-check whether you got the answer correctly or not. Okay, let's have a look at this one. As you can see, this is been colored very carefully, just inside A, but not going into either of the B and C, B or C. Hence, what we have to say is it's in A, definitely in A, and also we have to say it is not in B or C. So we see here B or C and the complement. So we're going to tell we are not in B or C area. It's a complement of that outside but inside the A. So that is the shaded area. Let's have a look at this one. Number 5. I have shaded everything outside of these three subsets, which means, well, if you are inside, what would you say? Well, it's all the union. Inside is union. The shaded region then should be the complement of it, because you are outside of the union. Hence, A union, B union, C complement. You must put a bracket. Remember that. You can't write A union, B union, C dash. That's a different subset. Moving on. Number 6. As you've seen before, just the one above, number 3, that's A intersection C. Here you have A intersection C, and then also B intersection C, and also A intersection B. So simply what we are looking at is the union of all the intersections. A intersection B, B intersection C, C intersection A. So you can write down each of them individually. You can write this one A intersection C or C intersection A. Then you apply, okay, I need the union. I want to put them together. That's how you form this particular flower shape. Okay. The second last one we have here, 7. Well, it's outside C, but in either A or B. So it could be either A or B or in both areas, but not in C. Hence we write down it could be A or B. It should be in there, and it should be not C, complement of C. So you can say C dash. Well, the final one is quite easy. Excuse me. A and B and C. Now we have the union A or B or C in this case. A or B or C. Simply the union of all. So we really need to write down here the universal set. Right. Now we are moving into the examples where we are going to shade based on our knowledge that we gathered so far or gained so far to color these diagrams. Well, as I mentioned before, you will get different variations of Venn diagrams. You have to read them carefully, especially which subset is which. Okay, for this one we are going to look at intersecting K and L. Hence we can color just the area for K and L. There you go, the one inside there. Here we are looking at K union L. So the K union L complement, which means if I indicate K union L, that's what we get. Complement mean outside. So not in that area, but inside M. Hence we can simply color not in that area, but in M is just that bit, that area. Let's color it. There you go. That's the area we are looking at. Now the third one, the complement of K, that means outside this orange but inside L or M. So it could be either L or M or both. Therefore we can color either L or both or in M. See the way we read? K complement and, here it says and. It should be outside K but inside here. Now the fourth one, K intersection L complement. So the intersection here is that bit. You are outside that and also you outside that. You color everything else, which means you are not coloring these two areas that I just indicated, but outside. Hence we can color the area outside. You have to do this carefully so that you are not going into either of the mentioned areas. Okay, nice. Now we go into the second last one here, number 5. We have L intersection, that means it should be inside L. It should be outside K union M. So the K is this one, M is that one. It should be outside, that means anywhere here, just outside, but it should be inside L. Therefore, I'm coloring area inside L but outside M or K. Okay, moving on. We have the complement of the union. So we have the union given. Now the complement. Union is everything. Since we have M as a subset of L, when you govern L, M is already governed already. So it's inside. The union is just in there. So the complement is outside. Therefore, we simply color outside. Okay, now we are progressing really well. Alrighty, let's have a look at this example. In this case, in this variation, we have been given the letters indicated each areas, and what we are going to look at is simply describing each of these areas in words. If you look at who prefers athletics, well, that's a circle which includes A, B, D, E areas, all 4 areas, not just A. But the A is the one that belongs to athletics, but neither cricket nor soccer. Hence, we can write down for A, prefer only athletics. I'm going to underline this word. Only mean just athletics, neither of the other. Now we can simply same manner, we can define C. Well, you can write easily, and G. The next area that we are going to look at is the B. Well, for the B says it's inside athletics as well as cricket, but not soccer. Hence, prefer write down that in a different color. But not soccer. Well, the area F is prefer cricket and soccer but not athletics. What is area D then? Well, think. Well, you are right. It's who prefer athletics and soccer but not cricket. Hence, you can simply do the area D and F. Well, they're similar to what we just written. I'll leave the ones that are ticked for you to write. Well, E is the area that belongs to all of these three subsets. Hence, prefer all can say all three sports. Well, the final one that we are going to look at is H, which is outside all of these three. We can say prefer none of these three sports. Well, now we identified the areas. Let's have a look at how we can put this one in more number sense, where we have the numbers. In this example, similar to the previous way of the Venn diagram presentation, but we have numbers. Now, how many students like or prefer athletics? Well, athletics is the blue circle. Hence, we have to add all the numbers in there. We have 20, 12, 10, and 8. Well, can you add this one in your head? I'm sure you can do that. It's different ways. If I were to do that, I would do 20, 10, 30, 38, and then 50. Or I do, just to cross check, 20, 32, 42, 50. Hence, simply 50. This is in fact number of if I say this set is A, this set is C, this set is S, that's NA, the number of elements in the subset A. Well, we can look at that one in our next lesson using the notation N here. Right. How many students prefer athletics and cricket? Athletics and cricket just in that area. So if I simply cover it up, that's that bit. That's what we are looking at. You have 10 and 8. We have 18 of them. There is no word call only in this case. We will have a look at that one bit later. How many students prefer only soccer? Only soccer just in that area. See that? It's only soccer. It doesn't belong to any of these two other subsets. Therefore 12. Now we get how many students prefer athletics. All that's a repetition. Now the next one we are going to have a look at is how many students prefer athletics or soccer. Athletics or soccer, either in athletics, the blue circle, or in this brown circle. Hence, we had 50 here already. Then we simply add 12 and 3 for the 50. That gives you 65. Let's read the next one and try yourself. I'll give you maybe 10 seconds. Okay, it says prefer only cricket and soccer. Only cricket and soccer mean it is in cricket and soccer but not in athletics. Hence, simply these three students only prefer cricket and soccer but not athletics. How many students prefer all three sports? Well, you have to add all. Now you can see we added earlier athletics or soccer up to 65, and then the rest is just here 14. That will give us 79. How many students prefer only one sport? One sport is only areas. That means this 20 who prefers only athletics, 14 only cricket, 12 who prefers only soccer. Now we have 20 plus 14 plus 12 equals 46. Let's go to the next one. None of these is sports. Well, the 11 outside. How many students in total? Well, total is everyone, the universal set. You got to add all of them. We already added here up to 79. You can see that's in here, number 6. And we add 11 onto that one. That gives you 90 as our final number. That is our total number of students. Okay, let's move on to the next one. Well, in this case, we are going to look at a bit more problems on sets. As you can see, this question is simply with percentages. Let's read this. Now let me define each of these sets. We are going to have the general form here, because in case if you given just the description like this, simply use the general form. Let's say this is P, this is Q, and this is R. Now let's have a look at filling each and every area here. The 60% watch P. Well, 60% is the one on the circle. So the circle should be 60%. That's what P means. And then we can put 52 and 55 respectively onto this. 52 and 55. Well, we assume the whole 100% just somewhere in here, and some outside as well. So let's have a look at what the numbers looks like. Let's have a look at the next information given here. It says 14% watch only P. Well, that will be here, isn't it? Just only P. Let me do that again. Okay, 14. Nice. Then we have 9% watch only P and R. Okay, if you look at P and R, P is the purple one, R is the light blue color area. Only means just in that area, just in here, where my cursor is. Okay, so which means we put 9% just in here, only P and R. And then we have 21% watch P and Q but not R. You can see the way that the question is being presented. if I say just watch P and Q mean just in here, that area, P and Q. If I say but not R, you can't be in R, which means outside R, the little area here on top. Hence we have 21% just in there. Well, now we are going to include the final one before we start all the other calculations for the leftover areas. 7% don't watch P, that means not in the purple area, but watch R and Q. It's another way of saying only R and Q. See the way the question is presented, only R and Q. That's 7% here. Well, we included those. Now let's have a look at the percentage of this area, the one common to all three subsets. The percentage who watch all three teledramas. We have 14 here, and then 21 and 9, if we add them together, 30, and here 14, 44. So the leftover is 16%. Goes into the middle. If I have these three, if I know the circle value is 52, we can find the percentage for only Q. Let's add 21 and 16, that gives us 37, and then 744, leftover is 8%. And now I have 3 here, 3 areas for light blue. The leftover can be obtained by subtracting these 3 from 55%. So let's have a look at that one. 16 and 7, you can do either way. 16 and 9, that gives you 25, and then 32, leftover is 23%. Well, we got the numbers now. We can answer the questions. Well, one thing that we didn't calculate, the one who did not watch either of the 3 teledramas. Well, have a look. 60% here, there's an easy way. We know this is 60% given that we have done all the calculations right. That's our assumption, which is pretty much 100% accurate, I guess, for you all. Right, 60%, then you add 60 to 23, that gives you 83, plus 7, 90, and then 8, 98%. Well, the union is 98%. What is the leftover? Legendary 2%. Well, that's actually fair enough, isn't it? Nowadays, people watch teledramas. Well, my example was perfectly right. Well, let's keep moving. Well, I'm a bit doubted. Probably everyone is actually watching teledramas. Maybe not. Well, leave that for the survey anyway. Okay, percentage that watch all 3 teledramas. Okay, all 3 just in the middle area here. 16%. We got that through. Nice work. And we can have a look at this one. The percentage that watch P but not R. Okay, P but not R. In P but not in R. That means in the purple but not in the light blue area. Just the 14 and 21 in red color. Hence we add them. 14, 21, that gives us 35%. Watch P but not the R teledrama. Well, percentage that watch only 2 teledramas. Okay, 2 teledramas is can't be 3, can't be the 16. It should be in AND areas without the 16. So 21, 9 and 7. 21, 9 and 7. 21, 9 and 7, 37. 21, 9 and 7. 37%. Watch only 2 teledramas. Okay, Duve Pute. So we discussed a few problems here today involving sets up to 3 subsets. Hope you understood them all and gain good knowledge about sets. I'm planning to do a few more video lessons soon. So if you haven't subscribed to my channel, please do so and press the bell icon so that you get a notification soon when I publish a video to this series. Well, until then, I would say best of luck and look after yourself. I'll catch you again in the next video lesson. Ayubowan, Teruwan Saranai.